El premio Nobel de Física 1997, William Daniel Phillips, estuvo en Colombia invitado por la Universidad Nacional. Sacó unos minutos para conversar con Pesquisa Javeriana y este fue nuestro diálogo. What was the most important moment in your research?
Well, I'm guessing that the thing that I'll be most remembered for is finding out that the temperature you could get with laser cooling was a lot lower than what everyone thought. The way that happened was, well, we'd measure the temperature and it agreed with what the theory was, but we didn't do a very careful job. And then we started making other measurements that indicated there was something wrong with our understanding. And then we said, okay, let's measure the temperature. But it was hard to measure the temperature. So we had to invent some new techniques, and the result came out that the temperature was a lot lower than what the theory said was possible. Then we were frightened, because we knew that that wasn't possible, that the theory was very powerful, and everyone believed that you couldn't get temperatures that were lower than what the theory predicted. So we said, we better be careful. So we developed some other methods for measuring the temperature, and slowly we came to the realization that yes, the temperature really is colder than what everybody thinks is possible. And that was a really big moment, but it wasn't exactly a moment, it was a process where we came finally to this understanding that what everyone thought had been wrong. And you know, that's what every scientist dreams of being able to show that what everybody thought was wrong. But let me say it a little bit differently. There are problems that are too hard for us to solve today. Interestingly, a lot of these problems are easy to state, but hard to solve. And what I would really like to do is sometime in my lifetime is to solve one of those problems that is easy to say and hard to solve. We could use a quantum computer to do that, but we don't need to. There are other ways. Quantum simulation, where we make our atoms behave in the same way as the model for the problem, allows us, in principle, to solve problems with nature itself. Now, I think we're very close to being able to do that, to being able to solve a problem that no computer can solve, but solve it with a physical system that looks just like the mathematical model.
Will you be working and thinking until the last day of your life?
I hope so. If I don't, in the end, suffer from dementia, I hope my friends are kind enough to tell me that I am. If that happens, I don't want to give up working, because working on physics is so much fun.